Today we will study about motion. Okay. In motion, first we will study about rest position. Rest is a position which does not changes its position with respect to time. Means object is said to be at rest when its position does not changes with time. Its position does not changes with time. Then its position does not changes with time. If we have any object and its position is not changing with respect to time, as the time goes, its position remains same, then we say that the body is at rest. Another, what we have to study is a term motion. Motion. A body is said to be in motion, is said to be in motion when its position changes with respect to time. Means if we consider a briefcase, if we consider a briefcase kept in a kept in a moving train, then that briefcase which is kept in the train is in motion with respect to somebody else who is watching it from outside the train, and it is at rest with respect to a person sitting in the train. Means if we have any body and it changes its position with respect to time, then we say that the body is in motion. Means if it is not changing with time, then it's at rest, and if it is changing with time, then it is said to be in motion. Now we will study about the concept of point object. When the size of object is much less in comparison to the motion or the distance covered by that body, then we consider that the body is point object. Means हमारे पास जो बॉडी है, अगर वो बहुत छोटी साइज में है और उसका जो डिस्टेंस कवर्ड है वो बहुत ज़्यादा है, तो हम ये कंसिडर करते हैं कि वो जो बॉडी है वो एक पॉइंट ऑब्जेक्ट है, बिकॉज क्योंकि उसने जो डिस्टेंस कवर किया है विद रिस्पेक्ट टू टाइम वो बहुत ज़्यादा है। इसीलिए हम ये मानते हैं दैट वी कंसिडर कि वो एक कैसा ऑब्जेक्ट है, पॉइंट ऑब्जेक्ट। ये हमारा कंसेप्ट है जब हम मोशन को स्टडी करते हैं, किसी भी ऑब्जेक्ट को किस तरीके से हम कंसिडर करते हैं। नाउ वी विल डील अबाउट द फ्रेम ऑफ रेफरेंस। Frame of reference is used to locate the position of any body which is moving. Means if a body is in motion, then it must be moving with a certain position. Means जो भी body motion में है तो उसकी position जो है वो change हो रही है with respect to time. तो हम एक frame लेते हैं जिसके reference में हम उसकी position को calculate करते हैं या locate करते हैं. तो वो जो part होता है that is a frame of reference. इस फ्रेम ऑफ रेफरेंस के बेसिस पर हमने मोशन को 3 टाइप्स में डिवाइड किया है। मींस फ्रेम ऑफ रेफरेंस इज यूज्ड टू लोकेट द पोजीशन ऑफ अ मूविंग ऑब्जेक्ट। Motion. Now we will deal about motion in 1D, 2D and 3D. Motion in 1D. If we consider a coordinate system, then we have x-axis, y-axis and z-axis. Means we have 3 coordinates, x, y and z. If position of any object changes with respect to one coordinate, means हम थ्री में से एक कोऑर्डिनेट को ले लें, दैट इज एक्स, इधर वाई और जेड, किसी भी एक को ले लें और इट्स पोजीशन, इफ अ मूविंग ऑब्जेक्ट changes its position with respect to that only coordinate, then we say that it is a motion in 1D. Okay, means when only one coordinate out of three coordinates, specify specifying the motion, the position. Now we will study about motion in 2D. In 1D, we have only one coordinate system which was used to specify the position of an object. If two coordinates out of three coordinates specify the position of an object, then it is a motion in the 2D. मीन्स जब हम 1D की बात कर रहे थे तो हमने एक्स वाई जेड में से सिर्फ एक ही कोऑर्डिनेट सिस्टम को लिया था, बट जब हम 2D की बात करेंगे तो हम किन्हीं भी वी विल टेक ईदर टू कोऑर्डिनेट्स, हम कोई से भी दो कोऑर्डिनेट्स को चूज करेंगे और वो दोनों कोऑर्डिनेट्स जो हैं दे विल स्पेसिफाई द डायरेक्शन, दे विल स्पेसिफाई द पोजीशन ऑफ एन ऑब्जेक्ट. व्हेन only two coordinates of out of now we will deal about motion in 3D. Motion in 3D. When all three coordinates specify the position of a moving or of a position of an object, then we consider that it is a motion in 3D. Means x, y, z all are taken which specify the position of a object. Then it is a motion in 3D. Means all three coordinates are changing with respect to time. When all three coordinates specify the position then we consider that it is a motion in 3D. Now we will take examples. First, we have discussed motion in 1D. Whenever the object is falling freely under the action of gravity, whenever it's falling, its height is considered. When it is height is considered, then only one part, only one coordinate is taken. Then it is a motion in the 1D. But if we talk of motion of a coin on a car and boat, it is a motion in 2D. And if we consider a kite flying in the sky is a motion in 3D. These are the examples which specify that which part of coordinate is used to specify the position of a moving object. Now we will study about types of motion. First we will study about a linear motion. There are basically three types of motion, among which first is the linear motion. The motion of a moving car is considered as a linear motion. Means when it is along a straight path, when it is along a straight line, then we consider that the motion of a moving body is a linear motion. Means the motion of a moving car is a linear motion. The motion moving car is a linear. Second type of motion is rotatory motion. Whenever a system or whenever an object is rotating, for example, if we consider a fan is rotating, so this motion is known as a rotatory motion. When there is a rotation, means when there is a circular path which is traced by the moving body, then we say that a moving object or the moving object has a motion, that is rotatory motion. It is rotating and its position is changing with respect to time as it rotates. So the motion. Next, we have to study about oscillatory motion. We have a simple pendulum. For example, we have a simple pendulum. Whenever it rotates, whenever it moves, means its motion is from to and fro. So that motion is an oscillatory motion. Means the motion of a simple pendulum. Whenever a body oscillates, for example, a simple pendulum oscillates, whenever a body oscillates and it has a motion, for that oscillation, then that motion is considered as an oscillatory motion. Now, in physics, we deal or we come across many quantities like motion, then we take time, length. We have many quantities in the physics. Now we have classified them in basic two quantities. Means now we will study about the type of quantities in physics. Type of scalar quantity is a quantity which depends only upon the value of that particular quantity. It does not have any relationship with the direction in which the quantity is taken or in which the quantity is considered. These are the values which depend only upon the magnitude of that quantity. The physical quantity which depends only on the value are scalar quantity. Example, distance, speed, etc. Whenever we talk of distance, we never used to specify the direction in which the distance or in which the body is moving. And whenever we talk of speed, we only take the value with which that body is moving. We never used to specify the direction in which the body is moving. We only specify the value in both the cases. Thus, distance and speed are considered to be the scalar quantities. Next is vector quantity. The physical quantity which depends on value as well as on direction are considered or are said to be the vector quantity. means in displacement, in velocity, with the value of both these physical quantities, we have to specify the direction also. Means if we talk of velocity, then with direction, with value, we have to specify the body is moving east, west, or south. In any direction it is moving, then we have to specify that particular direction also. Now we will deal about the representation of a vector, means how these vector quantities are specified. If we say that this AB is equal to P vector, means P vector is equal to AB vector, then this A is known as the tail of vector, tail, and this B is known as head of vector quantity. Means this P represents the AB vector, in which A is said to be tail of the vector and B is said the head of the vector. If we want to calculate the magnitude of B, then it is represented as modulus of P. This is how we can represent any vector quantity. We have discussed there are two types of physical quantities. One is scalar and other is vector. We have seen that how we can represent the vector quantity. Now we will study about the difference between scalar and vector quantity. First point of difference is that it tells only the value, means the scalar represents only the value of the any physical quantity, but vector quantity tells us about both value as well as direction. As scalar quantity depends only on value, means if we want to change the quantity of a scalar part, then we have to change the only part as value. Means if there is any change in the value, then the quantity will be changed. Vector quantity depends on value and direction both. Means if anything that is value or direction, either value or direction is changed, then the quantity will be changed. Scalar quantities do not depend on direction, thus they follow the simple ordinary algebra that we use in mathematics. But vector quantities are dependent on direction. So these quantities obey the another algebra that is particularly made for such quantities, that is termed as vector algebra. Means scalar quantity obeys the ordinary algebra of mathematics, while vector quantities obey the special algebra which is meant for only these quantities, which is termed as vector algebra. These are the three differences which are specified between scalar and vector quantities. Now we will discuss about the most important scalar quantity. Distance is the actual path that is traveled by a body in a given period of time. As it does not depend upon the direction, thus it is a scalar quantity. Next we will study about displacement. Displacement is basically a distance, but it is in a one particular direction. Means the displacement is the shortest distance between any two points. As it is dependent on direction, so we consider it that it is a vector quantity. Means the displacement is the shortest path which can be covered between any two points. A man is at position A. Okay. He wants to go at C position, but before that, he want to go to his friend. Means a person living at A wants to go at C, but before going to C, he want to meet his friend, which is at B. If the distance between A and B is 5 kilometer and between B and C is 3 kilometer and the shortest path is 4 kilometer, then if we want to calculate the displacement and the distance, then the distance covered by the man starting from position A will be AB, because from A to B he has to go as he wants to meet his friend, and after B he moves to C, that is AB plus BC, that is equal to 5 plus 3 kilometer equal to 8 kilometer. It is the actual path that is covered by the man moving from A to C in between B. Now if I want to calculate the displacement of a man, then his initial position is A and final position is C. The distance between initial and final position is 4 kilometer. So his displacement is 4 kilometer.